Welcome to all. From this video, we are going to start the course called Data Structure. In this video, we are going to discuss about the introduction and overview part of the Data Structure course. And in the first topic, we are going to discuss about the abstraction, abstract data type and data structure concepts. So before getting into topic, let us clearly understand the roadmap to understand the course data structure. So in this roadmap, before start to studying the data structure, we want to know the basic foundation concept called abstraction and abstract data type. These are the foundation basic core concept for the data structures. So first we want to understand what is abstraction and what is abstraction data type, and then we want to move on to data structures and data types of or else tools and implementation details. So how this data structure is going to be more important for data science students? Because the data science students are going to in future they're going to handle with big volume of data. So they want to efficiently handle the big data, as well as they want to optimize their algorithms, and also they want to find the better ML models. They want to perform feature engineering and the cleaning of the data sets. All these processes are going to be carried out by data science students. So for all these processes, the basic is data structure. So what? The data structure is more important for data science students. So directly, before directly diving into the data structure, we want to make a clear understanding about the abstraction. The abstraction in the sense, in a word, we can say that data hiding. Abstraction means data hiding. So the abstraction is going to expose only the needed features or essential features to the user, while hiding the internal implementation details. The simple principle is it focuses on essential features and hides the internal implementation detail. This is called abstraction. So in this abstraction, there are two types. One is procedural abstraction and another one is data abstraction. For procedural abstraction, let's say some example. In a Netflix OTT platform, when the user tap the play button, they only care about what it does. For example, the user was new to Netflix OTT platform. He opens the app and there he saw a play button. He going to press that play button, tap the play button, and he only cares about while pressing the play button, what functionality it going to do. That only cared by a user. But how this process is carried out or what functionalities are used, all these are don't care by user. So this is called procedural abstraction. And in the second type, data abstraction, think of the same Netflix OTT platform. There is a if there is a movie video got played and the movie video is playing. At that time, the user planned to added this to their watch list. So the user going to tap the added to watch list button, which add the particular movie to their list, or they can remove it from the list. But the user no need to care about the technology what is used to store this particular data. So hiding the details of data, how it is stored or what technology is used to store that data, or what servers are used to store this data, handle this data, these all details are hidden. This is called data abstraction. So why abstraction? Why this much of abstraction is this much of important? The main impact of abstraction is it will reduces the complexity. User can deal exclusively with the high level operations without worrying about the raw mechanics. So it reduces the complexity and it improves the maintainability. In the sense, the internal implementation changes which cannot be affected the end users. Without affecting the end users, the internal implementation changes can be carried out. This is called improves maintainability. This is due to abstraction. And the third main impact is it promotes the reusability. So the abstract modules which will be served as a universal component, and we can reuse it across different contexts as per our need. So the mainly it promotes the reusability, and final one, it enhances the modularity. So due to this modularity, we can safely divide our overall process into modules. So one module is not dependent to each other. So if the one module got affected, then it doesn't one module is got affected, then it doesn't affect the another module. So it will be very easier to fix that module and rescheduling it. So enhancing the modularity is an impact of abstraction. So these four are all the impact of abstraction. And now let's get into the data structure. What is data structure? Let us consider the library scenario. Imagine in a library there are millions of books are available, but without a system catalog, without a system, if we try to find any one of the book, means the searching is very impossible, and it takes more time consuming. So if there is a system, and if there is a well organized structure in a library, they had planned, they had placed books in a subject to category wise ordered, means then it is very easy to find a particular book or search a particular book. So this is a real example of structuring the data. So the definition makes simple. Data structure means it is a systematic way of organizing, storing and managing the data. Why we are organizing, storing and managing the data? For efficient access and efficient modification. So if we organize the data in a systematic way, means then we can easily retrieve the data, or we can easily store the data, or we can easily perform any modifications. So this is the proper definition of data structure. Why DS is important for DS, which means why data structure is important for data science? Because massive data sets are processed, searched and stored in our day-to-day life. So for efficiently manage all these massive data sets, data structure concept is very important. Why data structure matter? Day to day it involves large amounts of data in a real world. So data structure provides many methods to organize such data. For efficient data retrieval and storage, and for memory optimization, even utilizing the hardware resources in an efficient way, and for maintainability, clean organization makes code reusable and modular, and then faster, making the algorithm execution faster. For all these purposes, data structures is a main need. Here there is a classification of data structure. In data structure there are two data types, which is primitive data type and non-primitive data type. Primitive data type in the sense the basic data type which are all be language dependent, which are all already built in programming languages. This is primitive data type. We had seen in many of the programming languages. And in non-primitive there are two types of data structures, and linear structure and non-linear structure. Linear structure in the sense a sequential structure, sequential order. The order of elements are going to be in a sequential order. So this consists of four types: array, linked list, stack, queue. And in a non-linear structure, it goes to arrange the elements in a hierarchical structure or in a node to node structure. So for this there are two types called a tree and graph. So now linear versus non-linear structure. Linear, as the name suggests, it is elements are going to be arranged in a sequential order. So each element has exactly one predecessor and one successor, except the first and last element. Okay. So here the traversal going to be a single run traversal. Examples of linear data structures are array, stack and queue. So here predecessor and one successor in the sense, for example, here there is an element called A, here there is an element called B, and here there is an element called C. So for A, the current element is A. For A, the predecessor is B and successor is C. So the element before the current element, the element after the current element. This is called predecessor and successor. So in linear data structure, except the first and last element, each element has one predecessor and one successor. In the non-linear data structure, the elements are not going to be arranged in a sequential manner. So they are all going to be in a hierarchical or network based relationship. So it requires, the traversal requires a complex traversal rather than a single run traversal. Here each element can have more than one predecessor and one successor. So which means for example the A can linked with B at the same time it can linked with C. This is possible only in non-linear data structure. So the A can have more than one predecessor and more than one successor. Here there is a traversal mechanism has been displayed. In linear data structure, elements are going to be traversed in a sequential order and one predecessor and one successor. So for example, this element 2 predecessor is element 1 and the successor is element 3. And in non-linear data structure, the elements are going to be arranged in a non-sequential manner, which means one node can be linked with more than one nodes, and the traversal mechanism requires specialized versions like example depth first search, breadth first search. So examples of this non-linear data structure is tree and then graphs. Now we clearly make an understanding about abstraction, data structures, common definition of data structure. So the main concept is here the abstract data type. So abstraction means hiding the data. Abstract data type means, so to hide the data, what are all types were provided. So that's called abstraction, abstract data type. That is, it going to provide a mathematical model to store the data. It is going to provide a mathematical model, which means it going to define only what to do, and it doesn't care about the implementation detail. In abstraction, we hide the data. The data is hide. In abstract data type, to hide that data, what model is going to be suggested? What model is going to be suggested? And what operations are going to be carried out? This is what abstract data type. So ADT is characterized by the main three characteristics. They are called domain, operations and axioms. So domain means the set of values that ADT can hold, which means abstract data type. The values holding by abstract data type is called domain, and operations means the functions that can be applied to that particular data, which means operations like insertion, deletion are all going to be applied on that particular data. And axiom means while applying the data, while applying the operations, there must be some rules for particular operations. That is called axiom. So what is the difference between, here comes a question that what is the difference between ADT and data structure. So ADT in the sense abstract data type, the viewpoint of ADT is purely logical only, the mathematical models. It doesn't care about the implementation details. But the data structure means physical and implementation view. The viewpoint is on implementation. And the focus of abstract data type is on what operations are going to be carried out, and the data structure defines how the operations are carried out. For example, let us consider an example called stack. Stack is one of the abstract data type. It is a logical model. In this stack, we can perform the operations like pop, push. These are all operations can be carried out by stack, carried out in stack. But This ADT doesn't care about the implementation detail. How these operations are all going to be carried out. It doesn't care about it. The data structure will care about it. So implementing the stack using array. This is called data structure. So array is a data structure. Through this array, we going to implement the stack data type, and or else using linked list. So these are the implementation parts. Okay. So the ADT is not a language dependent. It is independent to any languages, which means we can use abstract data type in any type of languages called C, C++, Java, or else any programming languages. Data structure part like array, linked list are language dependent implementation. So here clearly there is an examples called stack ADT, and the data for data structure is an example called stack using array or linked list. The purely data structure means it is a methodology part. Okay, the first example called stack ADT. Stack in the sense it is a collection of elements of the same type, and the elements are going to follow the last in first out order principle. So which means in a stack the stack will follow LIFO order. The element which is inserted last will be deleted first. This is the concept called last in first out. So these are all the operations which can be done in stack. Push, which is insert the element, and pop, which removes the element and update the top of the stack, and peek or top, which returns the top element of the stack. Is empty. This operation is mainly to check whether the stack is empty or not. So it returns the answer as a true or either false. Is full, which is used to check that the stack is full or not. It also going to return either true or false. This size function, which is used to calculate number of elements which are all stored in the stack. These are all the operations performed in stack. Now let us see a simple example here. Here there is a stack which is empty. Now we try to push the element called 10. So the 10 got stored in the stack, and now the top element of the stack is 10. Again we try to push another element called 20. So the 20 got inserted. Now the top of the element got updated. So now the top is 20. So the top element of the stack is 20. At the same time, now we going to perform the next operation, pop. We try to pop the 20. So now the 20 has been removed from the stack. After that, the top position need to be get updated. Now the top of the stack is 10. This is the process of stack. And here the ADT doesn't, that stack ADT doesn't specify the implementation part at all, which means for implementing these operations, which concept is going to be used, either array or linked list. This is not carried out by ADT. And the next example is Q ADT. So Q also a collection of elements, and then it follows the FIFO order, first in first out order, which means the first entered element will be first exited. So here some of the operations which are all performed by Q. One is NQ, inserting the element is called NQ, and DQ means removing the element. Here there is no top and all. Here there is two main things will be there, front and rear. Front means returns the front element, rear means back of the end of the element, end of the queue. And is empty function, which is used to check whether the queue is empty or not, and is full, which is used to check whether the queue is full or not, and the size, it will check that number of elements in a queue. So this is also can be implemented using array or linked list, but the ADT doesn't care about it. In queue there is two concept mainly called front and rear. So here let's see an example. Here the queue is empty. So this is a rear part of a queue, and this is the front part of queue. When queue is empty, both the front and rear are in the same position at the time of queue is empty. So now we going to enqueue the element called 10. So the 10 got inserted in the queue, and now the rear and the front will be the at the same time the element will be inserted only at the rear end, not at the front end. The element will be removed from the front end. Okay, this is the difference between stack and queue. And now we try to insert the element 20. So the position of 10 will be moved, and after that the 20 will be added at the end. This is the process of queue. Now the front position will got updated. Okay, so the front element of the queue is 10 and the rear element of the queue is 20. Now we going to perform dequeue operation. So we going to remove the element called 10. So after removing the element, we want to update the front position. Again the front of the element is 20. Okay, next example, next data type, ADT data type is list ADT. It is an ordered collection of elements, which means here there is an ordered collection, and each item maintains specific sequential position, as well as the operations or insert this is a position value and this is element. So inserting a element at a position is possible in list ADT, and deleting the particular element if there are 3 elements in a list. Now I want to remove this particular element, means then I want to mention the position also in a delete operation. It will remove the particular element that in a particular position. And find x, which will finds the position of an particular element, and get position, it retrieves the element at a position, and is empty, which will checks whether the list is empty or not and returns true or false. The size means number of elements in a list. So this can also be implemented using array or linked list. So here some examples. This is the list. There is a link between 2 elements. So we can remove any elements from any position. Also we can insert any elements into any position. This is possible in list ADT. Okay, this shows the relationship between abstraction, ADT and data structures. So the main relationship, let's see first the abstraction hide the implementation and shows the essentials. After that the abstract data type goes to applies abstraction to data, which means data plus operation without implementation part. So this for example here n numbers are available, and for this n numbers what interface we were going to use, whether stack, whether queue or list. If you use list, if you use stack means collection of elements, the stack behavior is LIFO, and these are all the operations can carried out on these elements. This is ADT. Data structure, in data structure the actual implementation will be carried out using any programming languages, and in the programming languages using the implementation methods such as array or linked list. So this is the relationship between abstraction, ADT and data structures. And one more thing, next topic, primitive data structures and types of data structures. So primitive data structure, in the sense it is a basic data types which is directly supported by any programming languages. So why we are going to study about these basic data type means these basic data types are the foundation to develop complex data structures. For the complex data structures, these are all the base. So this common primitive data types are integer, and the first one is integer, which has 4 bytes, which occupies 4 bytes, and this is the range of the integer data type. And second one float, which occupies again 4 bytes. It is a single precision decimal numbers. And a double data type which occupies 8 bytes. It is a double precision decimal numbers. And the char data type which occupies only 1 byte. It is a single character, that is ASCII value from 0 to 255. And the bool data type which again going to occupies only 1 byte, which means it either going to return true or false. And the void data type, it doesn't occupies any bytes because it doesn't have any value. It is a return, no return type data type. Mainly it is used with functions. So what are all the operations can be carried out in this on this primitive data type means first arithmetic operations like addition, subtraction, multiplication, division and modular divisions. And in a relational operations like equal, not equal, less than, less than or equal to, greater than or equal to, or all these operations can be performed on primitive data types. And logical operations like and, not, or, and the bitwise operations and assignment operations, shorthand assignment operations, all these operations can be performed on primitive data types. Next, types of data structure. Basically, the data structure can be classified based on their structure and the memory layout. First, let's see about the base classification based on structure. There are two types. Called, one is linear. In linear data type, the first one is called array and linked list stack queue. Linear in the sense arrangements are in a linear order, that is sequential order. And in a second one is called non-linear data structure. In non-linear data structure, there are two concepts called tree and graphs. Here the arrangements are going to be in a hierarchical order. In a tree, the hierarchical structure with parent-child relationship is called a tree, and graph network structure with vertices and edges. This is the classification based on structure. And second one, classification based on memory allocation. In memory allocation, static data structure and dynamic data structure are the two major types. In static data structure, array comes under static data structure, because the array, the memory are allocated at the compile time. We cannot change the array size during the runtime. The main advantages are fast access, it will be easy to access, and no overhead of dynamic allocation, which means it doesn't care about allocating the size while runtime, so it doesn't disturb the OS, it doesn't disturb the operating system every time, so that will be reduced here. And the second one is called dynamic data structure. In that, the first concept is called linked list, and second tree, and third one graph. Here the memories are allocated at runtime using pointers and malloc functions, so runtime allocation functions. The main advantage, the sizes can be grow or shrink based upon the need. So the advantage of using it is efficient use and flexibility, because the sizes can be grow or shrink based upon our elements, data needed. But in array, if we allocate, for example, if we in array, if we allocate int ARR of 10, if we made a declaration like this, means while compile time it will allocates 10 spaces, but while runtime, if we had store only 4 elements, means it occupies only 4 spaces, remaining 6 spaces are wasted. So this is a main disadvantage in array. But in a linked list, tree and graph, there is no problem with that, because the memories are going to allocated during the runtime only. So based upon our need, the memory can be grow or shrink. This is the main advantage. So okay, we displayed more types of data structures and all. Among these types, how can we choose the right data structure for our need? So for this, we want to follow the nature of data, whether the data with us are in ordered or hierarchical. Based upon that, we want to choose. And then second one, operations needed. What are all the operations we were going to perform? Whether we want to we going to perform search, or we going to perform traverse. Based upon the operations, we want to choose the data structure. And the third main thing is based upon the memory constraint. Whether the memory is fixed memory or going to be a variable memory. Fixed memory, I mean static memory or dynamic memory. Based upon that, we want to choose our right data structure. And the main thing is time complexity. The operations which are decided by us, how fast it want to be executed. How fast that operation want to be executed. Based on that also, we want to choose the data structure. And frequency of operation. The operations are going to execute how many times, or it is a common operation, or based on that also we want to choose. Based on these 5 things, we want to choose the right data structure for our data to be get organized. So these are the introduction and overview parts. Based on these, here we displayed two questions. Question number 1, consider the following statement regarding the classification and traversal of data structure. Kindly read these questions and try to answer and try to post your answers in the comments. And in the question 2, question 2 also we had an abstract data type is formally defined as mathematical model that dictates the behavioral properties of a system. So carefully look at the options and choose the correct answer and post it in the comments. In the next video, we were going to the topic called analysis of algorithm. Okay, so if you have any doubts regarding this lecture, you can make your doubts in comments and I will clarify through that. Thank you.